So to understand electric potential, let us discuss some example. So first we'll see the flow of liquid. Does it depend on the amount of liquid? The well has got much liquid, where the tank which is kept on the terrace of the building has got no water. When we connect the pipe to the tank and well, will water will flow from the well to tank? No, it
No,
will
sir.
not flow. That means flow of liquid does not depend on amount of liquid. Though well has got large amount of water, but then also it is not flowing from well to the tank. But if suppose tank has got very small amount of water and you are connecting the tank to the well from the bottom, not from the top, and you open the valve, what will happen? That water will flow. So flow of water or flow of liquid or flow of fluid does not depend on amount. Then on what it is depending? It depends on
Right.
height or pressure. So flow of fluid does not depend on amount of fluid. Flow of liquid does not depend on amount of liquid or volume of liquid. But it depends on some other property. Okay, depend on height or pressure. So pressure is the condition that determines the direction of flow of fluid. Fluid will flow from higher pressure to lower pressure till
So can you read what you have written?
flow of liquid does not depend on amount, or we can say volume of fluid, but it depends on some other condition or some other characteristic, some other property, and that property is the pressure, or we say height. So liquid flow from higher pressure to lower pressure or higher altitude to lower altitude till they acquire the same pressure. Similarly, flow of heat depend on what? So flow of heat depend on what?
Temperature.
Temperature. Amount, suppose substance A has got more heat, B has got very less heat, but then also heat will flow from A to B or B to A. That will not depend on the amount of heat. It will depend on the another condition that we sometimes we call thermal condition, and that is temperature. So flow of heat also does not depend on heat or amount of heat. Contained by your. but it depends on some other thermal condition known as temperature. Flow of mass. Suppose a stone is at this height or it is very heavy. Flow of heat also does not depend on amount of heat contained by any object, but it depends on some other thermal condition known as temperature.
Sir, board is completely blur.
Tower is good, then also problem is there. What happened now? Now what is the condition?
Yes, sir, we can see it.
It was good, sir, but
Hmm?
It is clear now, sir.
Okay. So, flow of heat also does not depend on amount of heat contained by any object, but it depends on some other thermal condition that we call temperature. So, we are knowing heat always flow from higher temperature to lower temperature till what? Both the object come to the same temperature, and that we call
temperature.
thermal equilibrium. No, till the thermal equilibrium is achieved or acquired. Similarly, flow of mass also. A heavy stone or a small stone will always flow from higher level to lower level. And here, what is the condition? The gravitational potential. So that condition here is gravitational potential. The mass will flow from higher potential region to lower potential region. That does not depend on amount of substance or mass. So these are the examples which it says the flow does not depend on that particular quantity. Flow of heat does not depend on heat. Flow of liquid does not depend on liquid, whether liquid is small or whether it is large. Similarly, flow of charge also does not depend on charge obtained or charge contained by any object. So similarly, we say the flow of charge does not depend on amount of charge.
Sir, can you tilt the camera upwards? Sir.
Yeah, it is coming. What is the problem? Not coming. On the screen it is visible everything.
Coming, sir. Yes, sir, visible.
Similarly, the flow of charge does not depend on amount of charge present on any object, but it depend on some other electrical condition known as electric potential. So this is the concept, or this is the meaning of, or qualitative definition we can say, or qualitative meaning of electric potential. So how we define electric potential? So this electric potential is the electrical condition that determines the direction of flow of charge. So electric potential is the electrical condition that determines the direction of flow of charge from one object to other when kept in electrical condition. So same as heat, for the flow of heat, two conditions are required. One will be the difference of the temperature. The two objects must be at different temperature. Then only heat will flow from one object to other. And the second condition is they must be in thermal contact. Thermal contact means either the two objects will be directly in contact like this, or they are connected through any liquid or any metal which can transmit heat. That is thermal contact. Similarly here also, the charge will flow from one object to other if they are either connected directly, they are in direct contact, or they are connected through any metallic wire or any metallic conductor. Then only the charge will flow. Now in case of heat, there is only one type of heat. So heat will flow from higher temperature to lower temperature. In case of fluid, there is no different type of fluid or liquid. Positive liquid, negative liquid is not there. Positive heat, negative heat is not there. Or heat or cold, that is not the two different concepts. Only we use the heat, flow of heat only, not flow of cold. But here, in case of charge, there are two different type of charge, and they are opposite in nature. One we say positive charge, other we say negative charge. So naturally, they will have flow in opposite direction. So here we have to decide which charge will flow in which direction or from which potential to which potential. So conventionally we are considering that positive charge is flowing from higher potential to lower potential, and accordingly we give the definition of potential. So we say positive charge flow from higher potential to lower potential. And negative charge flow from lower to higher. Negative charge or electron flow from lower to higher. Positive charge, that we say cation, which flow from or proton, but generally proton does not flow, but cations are flowing. In case of electrolyte, we have seen there are two type of charges present. One we call cation, another we call anion. So that which is moving towards cathode, that we call cation. They are positively charged. So cations are moving from higher potential to lower potential, whereas negative charge or electrons are flowing from lower potential to higher potential. And this flow will continue till what? Till potential difference is maintained. If they come to the same potential, the flow will stop. So this, for the flow of charge, potential difference is required or maintained. The flow of charge will stop when the two objects come to same potential. Or their potential difference is zero. So this is the quality of electric potential. By this definition, we are knowing what electric potential is doing, or what is the role of electric potential in the flow of charge. But by this definition, we can't measure electric potential. So now we are going to discuss quantitative definition. When you are asked define electric potential, that means quantitative one. How we are going to measure? What is the meaning of 1 volt or what 2 volt or 5 volt? What is the meaning? So that we call quantitative definition. So for getting quantitative definition, we must know how electric potential is measured. For measuring any physical quantity, what we require? A unit. And what is unit? Some standard? No. Okay. So suppose we want to measure temperature. For measuring temperature, what do we require? Some reference. What is lower fixed point? What is upper fixed point? So reference we clear. From this, we are comparing this one. That is the measurement. Similarly, here also we will have to compare. With what we will compare? So we are comparing with the electrical condition of Earth. So electrical condition or electric potential of Earth is considered to be 0. Earth has got tremendous capacity to gain electron or to lose electron. If it is gaining 100 electron, then also electrical condition is not going to change. More million it can acquire, it can gain. So for the measurement of electric potential, the reference is taken as the Earth's potential. So electric potential of Earth is considered to be 0. Now, when a positively charged object, suppose this object is positively charged, this is connected to Earth, what will happen? The electrons will start moving. This we have done in class 8, no? So electrons will start moving and will reach to this place. Till this also become the potential of Earth, that is 0, till it become uncharged. So electrons will come from Earth and will neutralize this object. So this is 0 potential. And electron is flowing from here to here. Electron is negatively charged. So negative charge is flowing from 0 to, negative charge always flow from lower to higher. So 0 to above 0. Above 0 means positive. So electric potential of a positively charged object will always be positive. So electric potential of a positively charged object is above 0. It is positive. Maybe plus 2 volt, maybe plus 5 volt. So it is higher potential. Means above 0 we say. Now we consider another object which is negatively charged. If this object is negatively charged, what will happen? When it is connected to Earth, this is the symbol of earthing. Some other symbol is also there. This is also the symbol of earthing only. So don't be confused if this symbol is given or a previous one. Both are symbol of earthing only. It is connected to Earth. So what will happen now? Now these electrons will move from the object. So electrons from the object will move to the Earth. That is, this is lower potential, this is higher potential. Lower, that is below 0. Below 0 means negative. So electric potential of negatively charged object is below 0. That is negative. So this is the concept of 0 potential, higher potential and lower potential, means not higher, positive potential and negative potential. So with plus 5 is there, plus 10 is there, that plus 10 is higher, plus 5 and minus 20, plus 5 is higher. So higher and lower, always comparison is there. So if the object is positively charged, its electric potential will be called positive. If object is negatively charged, its electric potential will be called negative. Now, yes, still here any confusion, anyone? So electric potential, the qualitative definition means it shows the quality. So this is we call, it is an electric condition that determines the direction of flow. Whether when the two objects are kept in contact, suppose so this is object A, it has got plus 5 coulomb charge. And there is another object B, it has got plus 2 coulomb charge. Now A and B are connected. So charge will flow from A to B or B to A.
A to B.
Anyone?
A to B, sir.
A to B. Who is saying? Okay, A to B. One answer I got, A to B. Other one? No. All are united. Any other answer? See, out of 31, no other answer is coming. Yes, Tiwari, Aryan Tiwari. No answer? You are sleeping or what?
Sir, A to B.
A to B. Why A to B?
Higher to lower potential, sir.
Sir, higher to lower potential.
A is higher potential. Who told? Yes? Yes, Manya? What were you saying? No, she has joined just now. Okay. So just now we read, what we read just now? Flow of charge does not depend on the amount of charge. And you are giving after seeing the amount. Answer you are giving after seeing the amount. It has got plus 5 coulomb charge, it has got plus 2 coulomb charge. So we assumed it is higher potential. Why it is higher potential? Till now we have not discussed like that. So here we can't say it will flow from A to B or B to A unless we know the potential. So here we will not be able to say charge will flow from object A to B or B to A. For example, suppose this water is placed here and an iron ball is, maybe this may have got very less amount of heat. If it is heated up to 200 degrees Celsius, if we take reference level 0, what will be? Mass into specific capacity into rising temperature of this ball. Whereas if suppose 10 kg water is at 50 degrees Celsius, it will have much more heat in comparison to this. Then also, when it is dropped, it will flow from here. So it may have very less amount of heat, it may have very large amount of heat, but then also, if heat is given, this is having suppose 20 calorie heat, this is having 2000 calorie heat, we can't say it will flow from here or here unless temperature is given. Similarly, by seeing the charge, don't decide charge will flow from A to B or B to A unless we know the potential. So without knowing potential, we can't say charge will flow from A to B or B to A. But suppose here, This is having minus 2 Coulomb charge. Okay. Then what will happen? Then without, yes. Yes, what happened to Hari? What do you want to say?
B it will be.
A to B or B to A?
B to A, negative to positive.
Negative to positive. So here, electrons will flow from B to A. This is higher, lower potential. Minus means below zero. Just now we have done. Plus means above zero. So this plus will always be more than minus. So it is plus 0.5 and minus 100 here. Then also this one will be higher. So positive charge flow from A to B as here. Generally electrons will flow. So electrons will flow from B to A. But positive charge will flow from A to B. And the current also will say A to B, though electrons are flowing from B to A. So direction of current will be opposite to the direction of flow of electrons. So flow of electron will be this way, but current will be this way. The direction of current we assume the direction of flow of positive charge. Though positive charge is not moving here. Flow is of electrons. So sometimes this we call electronic current. So electronic current will move from here to here. Okay, so we will leave up to here today. Next day we shall see the quantitative definition. How we define 1 volt or any electric potential quantitatively, means how we will measure electric potential. And when question is asked, that definition only you have to give. So this is what is electric potential, what is the function of electric potential, when we will say higher potential means positive potential, when we will say lower negative potential. These all concepts are based on this one. Okay, shall we leave up to here? Yes.
Yes.